Welcome to the YouTube channel PCMB tutorials. Today we are going to learn class 9th foundation subject chemistry chapter number 2 periodic classification, and this is our part 2. In previous part we have learned the discovery of elements, scientists who discovered the more number of elements, and then we have seen the Lavoisier's life story, who is called the father of the modern chemistry. Today we'll proceed with the periodic table, chemistry condensed to a page. The task of studying the properties of large number of compounds is made easy by the study of the elements that make up compounds. And to simplify the study of these elements, they are arranged in an order fashion known as periodic table. The marvel of the periodic table is as if the entire body of knowledge chemistry is condensed to a single page. Now our main topic is evolution of periodic arrangement. Evolution of periodic arrangement. So over here our first scientist is Antony Lavoisier. Antony Lavoisier. The first scientific attempt to classify the elements was done by Antony Lavoisier. He divided elements into metals and non-metals. Second was John Dalton. John Dalton. John Dalton proposed the atomic theory and published a list of atomic weights of known elements. Third was William Prout. Based on Dalton's theory, William Prout expressed the atomic mass of every atom of an element as an exact integer multiple of the mass of hydrogen atom. Then was the Berzelius. The discovery of more and more elements made it difficult to remember all those elements. Berzelius proposed a simple idea of using the first letter of each element as its symbol. Then was the Dobereiner. The first arrangement of elements as a periodic classification was proposed by Dobereiner, who arranged similar elements in groups of 3, such that atomic mass of the middle element was the arithmetic mean of the other 2 elements. A group of such 3 elements was called a triad. Sixth was Dumas. Dumas obtained a relationship in the increasing order of their atomic weights called homologous series. Then was De Chan Cortes. Deitch and Cortes arranged the elements in the form of spiral helix. Eighth one was Newlands. Newlands proposed a new system of grouping elements with similar properties. In this new system, when the elements are arranged in the increasing order, of the atomic masses, the property of every eighth element is the repetition of the first. This theory was called the law of octaves. Ninth is ordling. Ordling. Now, a few months after Newlands proposed his law of octaves, Ordling proposed a superior relationship and arranged the elements in the form of a table where elements were arranged in a vertical and horizontal columns. As he failed to realize the implications of his table, no part of credit was given to him for the development of periodic system of elements. 10th was Lauder. Lauder was 10th scientist. He related the atomic mass of an element with its physical properties like density, melting point, boiling point, atomic volume, and etc. The graph was plotted between an atomic volume of elements and their atomic masses. This curve was called the atomic volume curve, where the elements with similar properties occupied similar positions on the curve. Then was the Moseley. Moseley assigned a new property to elements called the atomic number, which laid the foundation of the modern periodic table. Then was Mendeleev. Mendeleev arranged the elements in the increasing order of their atomic weights and tabulated the elements then known in the form of vertical columns and horizontal columns. This was the first successful classification of the periodic table. And the 13th one was Bohr. Bohr modified the modern periodic law based on the atomic numbers to that of the electronic configuration. His table was called the long form of periodic table. Then there was the major contribution leading to the development of modern periodic table, and first was of Dobereiner trades. Dobereiner trades. Now over here the scientist which we are going to learn deeply is first Dobereiner. Already we have learned about Anthony Lavoisier. Another we'll learn about New Zealand, then Laudermeier and then Moseley. Also Mendeleev. Like this we are going to learn. First one is Dobereiner traits. I'll repeat the main part twice. So, in 1829, Dobereiner proposed that chemically similar elements exist as groups of three called triads, in which the central atom of an element weight, which is nearly the mean of atomic weights of the other two. I will repeat. In 1829, Dobereiner proposed that chemically similar elements exist as groups of three called triads, in which the central atom has an atomic weight which is nearly the mean of atomic weights of the other two. Now there are some examples of these traits. So example 1. Example 1 was lithium, sodium, potassium. Lithium, sodium and potassium. Then there is the example number 2, where calcium, strontium, and then barium. Example 3 is chlorine, bromine and iodine. Chlorine, bromine and iodine. Now we'll learn that how did he found the arithmetic mean. So the atomic mass of lithium is, atomic weight of lithium is 7, sodium is 23 and potassium is 39. He added the atomic weight of lithium and potassium and divided it by 2, means 7 plus 39 upon 2, and that was equal to 23. 23. This atomic weight 23 is of the middle element of this 2. Like that. The middle element's atomic weight comes approximate after adding and dividing the addition by 2. Over here, the calcium's atomic weight is 40. Strontium's atomic weight is 87.62 and barium's atomic weight is 137. Over here, by adding 40 and 137, we'll divide it by 2. So we will get 80. So we will get 88.5. 137 plus 40, that is 177 upon 2. So we'll get 88.5, which is approximate of the atomic weight of strontium, that was 87.62. Then there is example 3 that says chlorine, bromine and iodine. Atomic weight of chlorine is 35.5. Atomic weight of bromine is 80 and atomic weight of iodine is 127. 35.5 plus 127 divided by 2 gives 81.25. That is the approximate atomic weight of bromine. Now there is the significance of Dobereiner traits. Significance of Dobereiner traits. In this all classifications we learned that all these things, and in classification of elements into triads had a greater significance in predicting the atomic mass, predicting atomic weight or atomic mass. We found the atomic weights of the middle elements, so it's the theory that predicting the atomic mass and properties of the middle element and predicting the properties of the middle element. However, only a few elements could be arranged in such triads. Also, there are some reasons for rejecting the triads classification. Reasons for rejecting triads classification. First was grouping of all elements is not possible. This was the first point. So since the number of elements is large, it is not possible to group all the elements into triads. Second point was dissimilar elements placement in a triad. Like elements of a triad should have similar properties, but the elements with dissimilar properties can also be placed into triads. Like example of carbon, nitrogen and oxygen. 12 is the atomic weight of carbon, and oxygen's atomic weight is 16 and nitrogen's atomic weight is 14. 12 plus 16 is 28 and divided by 2 gives 14. 14 is the mean atomic weight of nitrogen, and it is also the real atomic weight. In this example, this is the wrong tried because elements with dissimilar properties are placed in it. Means the carbon, nitrogen and oxygen have dissimilar properties. They do not have the similar properties. That's why they are called as wrong tried. I hope you have understood this whole Dobereiner triads. In part 3, we will learn law of octaves by Newlands. Then we will learn Laudermeyer's contribution. Till that, I hope you have understood this Dobereiner trades and evolution of periodic arrangement. For any queries and doubt, you can join the Telegram link given in the description of this video. Like, this is the foundation of class 9th. We have covered the foundation of class 8th and 7th too. The links are given in the description. Please go and check through it. I hope you have understood till this. Thank you for watching. Let's meet in part 3. Thank you.